So I do not yet have your quests graded. I know it's been a whole week, but they're taking a little longer than I thought. That's good. Okay. So if you remember, our last class before the quest, we had a fire drill. Yeah. So today we're going to be covering 2 full lessons, which is a little bit more than we usually do. So we're just going to have to keep an eye on the clock a little more and make sure we get them both done. We're going to do lessons 20 and 21. And just to point out, your next quest is coming up on the 19th. So you've got a couple of weeks before that comes up. All right, so we're starting on lesson 20. Which is page 150 of your packet. Okay, so today we're going to learn how to factor the difference of 2 squares, and we're going to do some more practice factoring quadratic trinomials. Okay, so we'll have a little bit of new in this, and then some practice with the stuff we learned right before the quest. Okay, so we're going to start by multiplying out a few products using a box. Okay, again, if you know another method, if you learned lobster claw or FOIL in a previous math class, you're welcome to use those, but I'm gonna do the box. So if I want to multiply x plus 3, x minus 3, I make myself a 2 by 2 box. How do I know that it needs to be a 2 by 2 box? 2 terms in each factor. Yeah, we've got x plus 3 that has 2 terms separated by addition, x minus 3 that has 2 terms. Okay, so the number of terms dictates the number of little boxes. All right, so I'm going to have x plus 3 and x minus 3. And then we just find the area of each little box by multiplying its length times its width. So x times x gives me x squared. X times 3 gives me 3x. Negative 3 times x is negative 3x. Negative 3 times 3 is negative 9. So if I write this out, I get x squared plus 3x minus 9. But what do you notice about the plus 3x and the minus 3x? They cancel. They add up to 0. 3x's minus 3x's leaves you with no x's left. So this is actually just x squared minus 9. X squared is a perfect square. Is 9 in your list of perfect square numbers? Yeah. So let's just file that away for a minute. All right, so now I'm going to multiply using a box 7 minus y times 7 plus y. So I'll make another 2 by 2 box. 7 minus y, 7 plus y. And then we find the area of each little box. 7 times 7 is 49. 7 times negative y is negative 7y. 7 times y is 7y. Y times negative y is negative y squared. Okay. And then you notice the 2 terms on the diagonal there, the 7y and the minus 7y, cancel. So when I write out my final answer, it's going to be 49 minus y squared. 49 is a perfect square, right? It came from 7 times 7. And then y squared is a perfect square. It came from y times y. All right, let's do one more. 2x plus 5y and 2x minus 5y. I'll make a little tiny 2 by 2 box here. 2x plus 5y, 2x minus 5y. And then I fill in the boxes. 2x times 2x is, great, 4x squared. 2x times 5y is 10xy. Negative 5y times 2x is negative 10xy. And negative 5y times positive 5y is negative 25y squared. The 10xy terms, one of them's positive, one of them's negative, they cancel. They add up to 0. So my final solution is going to be 4x squared minus 25y squared. 4 is a perfect square. 25 is a perfect square, right? That 4x squared came from the 2x times the 2x. The 25y squared came from 5y times 5y. So based on our work above, we can try to look at our pattern of what happened and come up with a formula for going backwards, right, for factoring. So if I give you, instead of a multiplication problem, I give you these guys instead, you could go backwards by looking at the pattern that happened in the boxes. Okay, so if we look at x squared minus 9, if we were to go backwards, it factors to x plus 3, x minus 3. And the 3's came from the square root of the 9, and the x's came from the square root of x squared. 49y squared factors to 7 minus y, 7 plus y. The 7's came from the square root of 49, and the y's came from the y squared. And it's always plus and minus, plus and minus, plus and minus. So this is the formula for how to factor the difference of two squares. If you have anything that looks like a squared minus b squared, you can factor to a plus b times a minus b. So let's use our formula to do a few examples. So x squared minus 64. It's going to factor to a double bubble. And it's going to be, one is going to have a plus, one's going to have a minus, according to my formula. And then what are the numbers that are going to go in there? Numbers and or letters. Yeah, x plus 8, x minus 8. So the x came from square rooting the x squared. The 8 came from the square root of 64. All right, let's look at another one. 100 minus a squared, b squared. And we're going to have 1 plus and 1 minus because 100 is a perfect square and a squared, b squared is a perfect square, so our formula applies. Square root of 100 is 10, so I'm going to put a 10 in here. What's the square root of a squared, b squared? AB. Good. All right, so 3r squared minus 27, I have a little hint here to first factor out the GCF. Is there a common factor between 3r squared and 27? 3. So I'm going to pull out a 3 first. So that becomes r squared minus 9 after you reverse distribute the 3. And then r squared minus 9, I go, oh, r squared's a perfect square, 9's a perfect square. I can apply this formula to r squared minus 9. So I just copy the 3, and then I'm going to have a double bubble, and I have a plus and a minus, and then the square root of r squared is r, square root of 9 is 3. All right, x to the 4th minus 16. Okay, x to the 4th minus 16, so I'll do a double bubble. We have a plus and a minus because x to the 4th is a perfect square and 16 is a perfect square. So my formula applies. Right? So what's the square root of x to the 4th? X squared. So I put x squareds in here. And what's the square root of 16? 4. So I put a 4 here and here. But I'm not quite done. How come? Which one can factor? Which one fits our formula of a squared minus b squared? Minus 4. The formula we've been applying in all of these examples only applies when you have a minus between your two squares. So x squared plus 4 is as far as we can go, but x squared minus 4 we can apply the formula again. So we have a plus and a minus. Square root of x squared is x. Square root of 4 is 2. What? Because I copied it from the previous step. I just copied the x squared plus 4, right? And then I continued to factor x squared minus 4 became x plus 2, x minus 2. Yeah, x squared plus 4 doesn't factor any further. Neither does x squared plus 9. So you can say prime, right? Sometimes my math lab asks you to say prime, or you could say cannot be simplified. Great question. Let's see what happens. Like, if I think, so Abby has proposed that maybe this factors to x plus 3, right? It's definitely not x plus 3, x minus 3, because then that would multiply to x squared minus 9. So, but let's see what happens if I multiply x plus 3 times x plus 3. This is the beauty of factoring. You can always multiply it out and know if you're right. So if I multiply x plus 3 and x plus 3, I get x squared, 3x, and 9. So when I multiply x plus 3 times x plus 3, I get x squared plus 6x plus 9. Yeah, so that is not the correct factoring for x squared plus 9. You can only do it if it's subtraction. Turns out if it's addition, there's just nothing you can do. Yeah, we might have some other guesses, and I'll just save you the time and say they're not going to work, right? All right, so a few observations about using the dots formula, which is my abbreviation for difference of two squares. Subtracting, the word subtraction, the answer to a subtraction problem is a difference, so difference of two squares formula. It only applies if you have two terms separated by subtraction, each of which is a perfect square. It's the only time you can use it. You can't use the dots formula to factor a sum, like x squared plus 9. And sometimes you have to use the dots formula twice on the same expression, like up here in D. All right, so you're going to get lots of practice with the 2x2 box method in today's activity. But we left out one small but important detail in our last lesson about the 2x2 box. So here's a box, right? I already figured out what goes in every single box of the 2x2, and now I'm just going to factor the GCF from the first row. So I'm skipping a bunch of steps from the problem just so that I can show you the one missing piece. And then I'll review all of the other steps in a minute. So I'm going to factor out the GCF from the first row. So negative 6x squared and 9x. What's the common factor to those two terms? Definitely a 3 and also an x. Yeah, because they each have at least one x. So I think I'm going to pull out negative 3x. I just don't like having that negative in the front there. All right, so once I've done that, then I can figure out what goes across the top row, because you have to ask yourself negative 3x times what gives you negative 6x squared.
How do you find negative 3x?
I could have made it positive, right? It's just going to change what goes right here.
Okay, so
it's just going to change the sign there. That will also have to be negative, so it'll be a negative times a negative will give me the positive. All right, so negative 3x times what gives you negative 6x squared? 2x, very good. And negative 3x times what gives you 9x? Negative 3, great. All right, and then now I can figure out what goes in this last spot here by saying 2x times what gives me negative 24x? Negative 12, great. So our factorization is going to be 2x minus 3 times negative 3x minus 12. So 2x minus 3, do 2x and 3 have any common factors? No, so that is as simple as it can get, right? So that just stays. But negative 3x minus 12, do negative 3x and negative 12 have any common factors? Negative 3, yeah. So I actually can pull out a negative 3 from negative 3x minus 12, and you're left with x plus 4. So what I underlined in black here became what's underlined in black here. And then you can rearrange, right? You can put the negative 3 in the very front and then times your remaining factors, right? Because you can do multiplication in any order. So it's just kind of standard practice if you have a plain old number to write that first. But it's not wrong if you left it like that. All right, so I figured since it has been over a week since we learned the 2x2 box method, I'm going to go over with you the refresher that I was just going to have you read, right? But I think we're going to do it together. Okay, so the box method process for how to factor a quadratic trinomial. So I want to factor 6x squared minus 11x minus 10. First step is to draw a rectangle with 4 smaller rectangles in it. And then you put the first term in the top left, always, and the last term in the bottom right. Then you multiply those two terms together. 6x squared times negative 10 gives you negative 60x squared. Good. So we multiply the two terms on the diagonal, and then we start listing factors. What are some other things that can multiply to negative 60x squared? Because the two terms on the other diagonal have to multiply to the same thing as these terms. Okay, so underneath my product of negative 60x squared, I start listing all the ways I can multiply things together and get negative 60x squared. And each one has to have an x in it. And I got to think about the sign. My product has to be negative, which means one of my factors has to be positive and one has to be negative. Technically, you don't have to write all of these down. You can stop when you find the magic one, right? And what is true about the magic one? What are we looking for? They have to equal negative 11x when you add them up, right? When you look at the two factors, when they add together, they're supposed to equal the middle term. All right, so which of my factors, right? So to get negative 60x squared, I could multiply 1x and negative 60x, or negative 1x and positive 60x. I could do 2x and negative 30x, 3x and negative 20x, 4x and negative 15x. So these are just all ways that I can multiply things together and get negative 60x squared. Which of them adds up to negative 11x? 4x and negative 15x. That's the magic one. Because they add up to negative 11x, the middle term of the trinomial. So I put those two terms in the remaining boxes, and it doesn't matter which one goes in which. 4x, negative 15x. All right, so I just have redrawn the box down here. Okay. Factor out the greatest common factor from the first row. So this part we just reviewed, but we're going to go through the whole thing anyway. Common factors between 6x squared and negative 15x. 3, and how about letters? Should I take any letters out? X. They each have at least one x. So I'm going to take out a 3x. And then I have to ask myself, what should I multiply 3x by to make 6x squared? 2x. What should I multiply 3x by to make negative 15x? Negative 5. And what should I multiply 2x by to make 4x? 2. So my factored expression is 3x plus 2 times 2x minus 5. Okay? All right, so I'm going to have you do some practice. Whenever you can, factor out a GCF first. Okay, so that should always be the first thing you check for. You often can do the problem without doing that, but taking out a GCF will just make everything look simpler and nicer, make your life easier. Okay, so we're going to learn how to solve quadratic equations. So far with factoring, all we've been doing is simplifying. There have been no equal signs, just simplifying. But in this lesson, we're going to solve quadratic equations. Two methods we're going to learn. Okay, so if I wanted to solve x squared equals 16, I just need a way to get rid of the square on the x. So what undoes squaring? Square rooting, yeah. The opposite of squaring a number is taking the square root of that number. So I would take the square root of both sides of the equation, square root, and the square root of x squared is x, and the square root of 16 is 4, right? And it seems like that's totally legitimate, but we missed a solution because -4 is also a solution to x squared equals 16. Because when you put a -4 in for x, when you square -4, -4 times -4 is also 16. So the moral of the story is that when you do that method, when you take the square root of both sides of an equation, you have to add in a plus or minus. Okay? So it would actually look like this. You write x squared equals 16, square root both sides, add in a plus or minus on the number, right? So we end up with x is plus or minus 4.
Did you also have x plus 4?
Sure. That wouldn't be the answer, but that's another way of getting there. Yeah, so I'll do a little aside here. If you had x squared equals 16, right? If you move the 16 over, subtract 16 from both sides, so you have x squared minus 16 equals 0. And then you just recognize that that's a difference of two squares, and you could factor it to x plus 4, x minus 4, right? So I'm still not quite done because this is an equation I'm trying to solve for x, so I should end up with an answer that looks like x looks like a number. X is a number. So I'm not quite done, but the next piece of the lesson is going to talk about this, so let's just talk about it right now. Think of two numbers. If you're going to multiply two numbers together, don't think about this for a second. You're multiplying two numbers together and the answer is 0. What has to be true about at least one of your two numbers? Has to be 0. The only way to get 0 as the answer to a multiplication problem is if one of the numbers you were multiplying was 0. All right. So here, I'm multiplying two things together, x plus 4 and x minus 4. Those are just numbers once we figure out what x is. So multiplying two numbers together and the answer is 0, which means at least one of them has to be 0. So this becomes two separate equations, right? Either x plus 4 has to be 0 or x minus 4 has to be 0. Solve each of those separately and you get x equals -4 and x equals 4, which is the same solution I got up here, plus or minus 4. Okay. So when should you use each of these two techniques, right? So taking the square root of both sides is a good technique if the equation has an x squared term but no plain x term, right? So it's just got x squareds and numbers. So for example, 7x squared minus 1 equals 199 plus 3x squared. It just has x squared terms and regular number terms, no x terms. So that will work because I can get the x squared by itself and eventually square root both sides. Okay. So if I was going to do that, I want all my x squareds on one side, so I would subtract 3x squared from both sides. And I get 4x squared minus 1 is 199. Add 1 to both sides. I want to get the x squared by itself, so divide both sides by 4, and you get x squared is 50. and then square root both sides. So this is the new step that we just learned. Square root, put a plus or minus on the number side, and you get x equals plus or minus the square root of 50, which can be simplified, right, because we already know how to do this. 50 can be rewritten as 25 times 2, and you can take the square root of 25, so it's plus or minus 5 root 2. All right, but what if it has an x term? Okay, what if it has an x term? We can't do this same just square root both sides method. So if we have an x term, we're going to use this method that Sarah suggested up here, right? We didn't have to use it here because we could have done the square root of both sides. But the reason it's helpful is because it works when you have any x term at all. So basically, you want one side to be 0, right? Factor the other side, and then you're multiplying two things together, and the answer is 0. That means either one or both of your factors has to be 0. So you go from having one equation where you have two things multiplied equaling 0, and that splits up into two separate equations because we know one of those factors has to be 0, at least one of them. So then you solve the two equations separately, and you get 1/3 and -7/2. So let's do one all out where we have to actually do the factoring. Okay. So x squared minus 24 equals 5x. Start by putting everything on one side. I need one side to be 0 in order to use that special property where you multiply two things, the answer is 0. That only works if one side is 0. So I'm going to subtract 5x from both sides. So I have x squared minus 5x minus 24 equals 0. And then I have to factor that. Right? I have to try to factor x squared minus 5x minus 24. I'll do a little 2x2 box over here. Put in an x squared, put in a -24. So then multiply them and I get -24x squared. So I have to think of something that multiplies to -24x squared and adds to -5x. What do you think? -8 and 3. Good, that was fast. -8x and 3x, right? They multiply to -24x squared and they add up to -5x. All right, so we pull out the GCF from the top, we get an x. X times x is x squared, x times -8 is -8x, x times 3 is 3x. So this factors to x minus 8, x plus 3. And then I have two things being multiplied together. That's two numbers being multiplied together, and the answer is 0. At least one of them has to be 0. So I break this into two separate equations. X plus 8 is 0, or x, minus 8, or x plus 3 is 0. Solve each of them separately, and we get x equals 8, and x equals -3 are my two solutions. I think that's it for the demo. You can start the activities on page 160.